Welcome to all the Advanced Algebra II students from Mr. Patterson and Mr. Clendenin's class. Good to have you guys. Today your video is for May 4th, so at the top of your paper, please title it 5-4, write everything down as your notes, do the homework problems, upload the picture to the Google Doc, send it to us, and you'll get full participation. If you need any help, reach out to us on Google Hangouts, Google Chat, Google Meet. We can do a little virtual meeting with you if you really need, or email, and we'll try to get you squared away. Okay, today we're going to be exploring something that you guys have seen before. We're just going to go a little bit more in depth than what you have in the past. So you're going to write down a sequence. Now a sequence has a definition, and it's actually going to be a pattern. It could be a pattern of anything. Back in elementary school, you might have had a pattern of shapes. It went like triangle, square, circle, triangle, square, circle, so on and so forth. But we're going to have patterns of numbers as it's an algebra class. So here are your first three examples, and we're going to take you back maybe to more of a grade school style questioning of a sequence, where all you have to do is find the next term, or in other words, find the next number in the sequence. Now, when you had that, some were easier and some were harder, but you had to figure out the pattern or what was changing from number to number. So this would have been maybe the most basic style you would have saw in the past. When you go from 2, 5, 8, 11, 14 will be the next number. Now you can pause it to see if you know, but the pattern is I would simply increase or add 3 each time. So it'd be 2 plus 3 is 5, plus 3 is 8, plus 3 is 11, plus 3 is 14. So all I have to do is add 3 and 17 would be my next term. Number 2, some trickier stuff could happen in sequences. So again, you could pause right now and see if you know what the next number is, but I'll show you kind of what the pattern was that I thought of. I noticed that from here to here it was add 6, but then I minused 10. But then I added 6 again. Minus 10. Add 6. So what I should do next is minus 10. And when I minus 10, I get, I only get 3. So that would be the pattern. So the pattern can kind of like, I guess, change the pluses and minuses, but as long as you can find a pattern, you can find the next term. Now the pattern doesn't always have to be plus or minus. So how does 4 go to 12, go to 36? Pause right now if you want to try it out on your own. But the pattern would be multiply by 3. 4 times 3 is 12. Times 3 is 36. So we have to times 3. And when you take 36 times 3, you get 108. Now, everything that we just did on the board there should have at least been a review concept. You have seen sequences before, whether you knew their official term or not, and you have found the next term. But what we want to do is we want to investigate sequences a little bit more, see what's happening behind them, and how we can, obviously expand on what we already know. So the next thing that you're going to write down in your notes is you're going to say what is behind every sequence. So you can maybe put a star. This is kind of an important thing. It's over there on your margin. And you say a rule or equation. They mean the same thing. The rule is the equation. A rule or equation is behind every sequence. Now, what does that actually mean? Like, what do you mean by a rule or an equation is behind every sequence? Well, that rule or equation generates every number in the sequence. So here is what I want to write underneath it. 3, 6, 11, 18, 27, ... So this sequence could go on forever. Well, you might see the sequence, and you can pause right now, and you might be able to find the next term, but do you really know what's going on behind it? Well, here I add 3, then I add 5, then I add 7, then I add 9. So it seems like I'm increasing my addition by every odd number. So maybe next I'd add 11. Then I would add 13, add 15, add 17, and keep going down the line to get my sequence. But what if somebody didn't want the next term and they wanted the 133rd term of the sequence? Well, you wouldn't want to write down all those numbers till you got to the 133rd term. So there has to be an equation behind this. Now, it'd be very hard to generate it on your own, and we're not asking you to do that, but I just want you to understand that the equation behind it, and I'm going to show you the notation, is a sub n equals n squared plus 2. Now, you might think, how does that generate this sequence? Well, you need to understand notation first. Every term is labeled as certain notation, and it's kind of like this a sub n, where n is the number term. So 3 represents a sub 1 because it's the first term. 6, a sub 2 because it's the second term. 11 would be a sub 3 because it's the third term. 18 is a sub 4 for the fourth term. 27 is a sub 5 for the fifth term, so on and so forth. And what these little subscript numbers, they're supposed to be a little bit smaller in the bottom right-hand corner, would tell you what number to plug into the equation. And then when you do that to your equation or your rule, it will give you your term. So we're only going to try one of these, and you can pause and try your own. But I'm going to show you how a sub 4 really is 18 using this rule. So if I wanted to, again, once I know the rule for the sequence, I could find the fourth term by doing a sub 4, because 4 would represent the fourth term, or the fourth number in the sequence, this guy right here. Well, all I do is replace n with 4, so that n becomes 4. You simply plug in the number, and 4 squared plus 2. Well, that'd be a sub 4 is equal to 4 squared is 16 plus 2, and a sub 4 equals 18. So the equation is very important, because what if you wanted to find the 133rd term? Well, you would simply plug in a sub 133. Now, I don't want to do that because 133 squared is a really big number plus 2, but that would be the number way down the line in the sequence. So behind every sequence is an equation or a rule. You don't have to generate them, you just have to know how to use them. All right, so we're going to have 2 more examples in our notes, and we're going to see how these rules can be used to write a sequence or just to find a specific term. So number 4, write down that we are going to find the first 5 terms if a sub n equals negative 2n plus 1. All right, so you guys, all we're doing is we don't know anything about the sequence except the rule behind it. So using proper notation, if I want to find the first 5 terms, I would write a sub 1 equals, a sub 2 equals, a sub 3, a sub 4, and a sub 5, because that'd be the first, second, third, fourth, and fifth terms of the sequence. And I find them by plugging in 1, 2, 3, 4, 5. So for a sub 1, I'll plug in 1. Negative 2 times 1 plus 1. Now using your brain or your calculator, that's negative 2 plus 1 is negative 1. To find a sub 2, you plug in 2. Negative 2 times plug in 2 plus 1. Well, that's negative 4 plus 1 is negative 3. Plug in 3. Negative 2 times 3 plus 1. Negative 6 plus 1 is negative 5. And to get the next terms, you might already start seeing the pattern. Because if you wanted to, also, you could write them in order. You could write negative 1, comma, negative 3, comma, negative 5. And now you're probably seeing the pattern. Oh, it's minus 2 each time. So before I even use the rule, I probably know the next term is negative 7. Let's see if it is. So negative 2 times 4 plus 1. Well, it's negative 8 plus 1 is negative 7. Yep, negative 7 would be my fourth term. And then the fifth term, again, minus 2 one more time is negative 9, but negative 2 times 5 plus 1, negative 10 plus 1 is negative 9. And whether you box these as your final answers, you could just box everything, or you could box them written in order, but that is your first 5 terms of that sequence. And again, there's a rule behind it or an equation. Last example of the day, number 5. Here's why a rule or an equation is so important. If you want to find a sub 27, now what that means is it's the 27th number in the sequence. So it'd be the first, second, third, fourth, fifth, all the way down the line to the 27th number. And even if I gave you a sequence, you wouldn't want to just keep finding numbers and finally going, yay, I got the 27th number. But if you have the rule, it's honestly pretty simple to find the 27th number in the sequence. So we're going to find a sub 27 for a sub n is equal to n times parentheses n plus 1. Now, it's not the easiest rule in the world, but again, we can plug in numbers, so it's okay. To find the 27th term, I'm just going to write 27th term. The notation would be a sub 27, which was given in a problem. And all that means is that n becomes 27. So that becomes 27, and that becomes 27. So my equation becomes 27 times 27 plus 1. That's a sub 27 is equal to 27 times 28. Now that is not something that I normally do without a calculator. So I'm going to say a sub 27 equals, type it in my calculator, which I already have, is 756. And you should know what you found there. Is if you have the sequence, that'd just be the 27th number. So it'd be like a number, comma, number, comma, number, comma, number, comma, number, comma, number, and then all the way down the line is the 27th number in that sequence. That would be it. All right, you guys, this week we are going to explore sequences more. Now, there's going to be one tricky thing about the video tomorrow. It will say 415 Honors Algebra 2. That's what they did on April 15th. You're going to be doing it as May 5th. So you guys, even though the video, when you check it out on YouTube, is going to be labeled 415 Honors Algebra 2, that's not at all. Please make sure that you still put at the top of your paper that you did it on 5-5. I'll explain all that in Google Classroom as well. But if you have any questions or concerns, let us know, me or Mr. C, and we will help you out. Here are your 3 homework problems to add onto your paper and try them out. Let me zoom in. Number 1, you're just going to find the next term. Number 2, you're going to do what it says. And number 3, you're going to find the 43rd term. All right, you guys, good luck. And it's your boy, Mr. P. Have a great day.